all day I wrote 2019, so I'm going to write 1/23/2020 today. Are you proud of me? Okay. Okay, so what is this? A plus B or A minus B? How do we call it? Wait, does it have a name? When we add two quantities or subtract two quantities. Well, we normally say that this is a binomial, but if it has the square root of x in there, then it's not going to be a binomial. But let's say it's a binomial. When we add or subtract two quantities, let's call it a binomial. Now, what we are trying to do here is square a binomial. Does anyone remember the answer? Sometimes I'm looking to make sure that it's recording. Do we remember what happens when we square a binomial? Okay, so let's do that. This will be my page 2. So A plus B, everything squared. Can you see? Can everyone see in the back? Okay. Anyone wants to say anything about this? Okay, we have no idea then. Do you agree with this next step, though?
Yes.
Okay. Okay, so let's say for now we want to FOIL. So I'm going to distribute, and I'm going to distribute. We agree with that too, correct?
Yes.
Okay, so then we have a squared, and then we have plus ab, and then we have plus ab, and we have plus b squared. Do we agree with this?
Yes.
There is never, don't you ever be embarrassed or shy to say, I don't understand something? Always raise your hand or tell me what you think, okay? So obviously these two terms are like terms, which means they will be combined. So moving forward, we will not forget that a binomial squared is always, how do we call that? How do we call this? Yes, indeed. Every time we square a binomial, we will always get a trinomial. So here's an example. If you'd like to make one up for me, that would be fantastic. So going back to our little handout, we will write a squared plus 2ab and plus b squared. What do you think will happen if there is a minus between these two terms? Yes, yes, that's the only difference. Excellent. That will be the only difference. Either plus 2ab or minus 2ab. Nothing else changes. So can anyone give us an example of a binomial that you would like to square? All these topics that I'm reviewing with you at any point in time are crucial for what we're doing in this class. So anyone can give me a binomial.
3x plus 2y squared.
Thank you, Vicky. 3x plus 2y squared. How many terms are we going to write?
Like in the answer.
Yes. How many? Exactly 3, right? We expect a trinomial. So first we will square the first term. Can anyone square the first term for me? Right? Plus 2, because there are 2 identical terms. So please multiply these 2 quantities, and then the answer multiplied by 2, because there are 2 identical terms. Excellent. Thank you, Hannah. Plus the second term squared. That's it. Here is what I would like you to remember. That any first term plus any second term squared. Can anyone come up with a pattern for us? So first term plus second term squared, what is this? Perfect. Plus 2 times the first times the second plus, that's the pattern. Once you see the pattern, you cannot forget about it. So this is product plus the second term squared. So this is the product, 2 times multiply first term times the second term. Of course, the pattern is the same if we have minus. If the binomial has minus, then the trinomial has the negative sign in the middle. Perfect. Okay, now let's review the last one. That's another very important special product. Anyone remembers how to treat this? You can just FOIL it again. Let's FOIL it again and come up with the pattern. Very good. So if we FOIL, we get this. But this time something nice happens here. What is it?
The AB term disappears.
Correct. This is the difference of squares. Sorry, I wrote minus. I should have written minus, but by mistake I wrote plus. Sorry. This is a difference of squares. So it's a squared minus b squared. So what will be the pattern now? First term plus second term times first term minus second term. The answer would be?
First term squared minus second term.
Excellent, thank you. Any questions on this?
Yes, what is that first symbol? I don't know what that, is that a T, is that an F?
Yeah,
No, before that. Okay.
so this is first term, first term,
Okay.
second term, second term. Sorry about that.
I couldn't tell if that was an
Of
F
course
or a
not.
T, I couldn't tell what that was.
Yes, I agree. When I stand, there is no excuse. When I stand and I write, sometimes things happen, so my apologies. Now moving forward. Okay, so we're done with this then. So I'd like us to review other things that are super important for the course. I changed this handout from the one you're going to see in the videos. So this is not the same. And let's start working on whatever you want me to. If you say, let's not waste time on the first one, then I won't. If you say, no, I want to see the first one, we'll start with the first one, whatever you want. If you want to choose something else to start with, we can choose something else.
Start with the first one.
Start with the first one, very good. I think I'm on page 3. Yes. Okay, the first one has a point -2, 3, and we have 2x minus 3y equals 4. And this particular question has 2 parts, basically. Find the equation for the line that passes through the given point and is parallel to this line. And the second one, it says, it passes through this point, but it's perpendicular to this line. So part A, parallel, part B, perpendicular. So in part A, the scenario is this. I'm not graphing the line. I'm just giving you the idea. So in the first situation, we have this. When the lines are parallel, and the line that I am looking to find, or I try to find its equation, is that. And the second scenario, I have the line. This is still the line I don't have. This is still the same point as -2, 3. But this time, the line that is 2x, whose equation is 2x minus 3y equals 4, is perpendicular. It forms, the 2 lines form 4 90-degree angles. So let's start with the first scenario. What do we do?
I would convert the equation to the y equals mx plus
Correct, excellent. Thank you, Amari. Amari says this, solve this equation for y. Okay, so this would be 2x minus 3y equals 4, which means negative 3y equals negative 2x plus 4, which means y equals 2/3 x minus 4/3. Is this what you see? Is it a little blurry or is it clear? Okay, perfect. Okay, so then I wrote the equation. I moved this term to the other side. Please try, if possible, not mandatory. I will never, that's one thing I didn't tell you about me, I will never force you to use the method I present. Maybe somebody else teaches you a different method that is easier for you. Fine, use the method that is easiest for you, okay? So, but I do recommend, instead of writing minus 2x on both sides, I would like us to move away from that and simply say, if I move a term from one side to the other, the only thing that happens is, that's it, the sign changes. If it was positive on this side and I move it to the other side, it becomes negative. It's up to you. So after that, I will definitely divide by -3, but do not divide by -3 writing a fraction line and -3 in the denominator, because that will not serve our purpose. Our purpose is to find the slope. So divide term by term. I divided this by -3, I divided this by -3, and I divided this by -3. So now we know that the slope of the line that is given to us, I don't know if you want to call it M1 or M2, it doesn't matter, I'm going to call it M2, is 2/3. So this line has the slope 2/3. That means that the green line that I'm trying to find the equation for must have the same slope. Why? Because the lines are parallel. That's it. So if M1 then equals also 2/3, then I have to think of an equation, and we have two equations of the line. One which is y equals mx plus b, and the other one which is y minus y1 equals the slope times x minus x1. So one will be this, but this piece is 0 comma b, which is the y-intercept, which I don't have. The other option is, so this is the slope-intercept form. The other option is y minus y1 equals the slope times x minus x1, which is point slope form. I rested my hand on something here. I hope it goes away. Go away. Present a mode setup. I don't want to set up anything. Should go away in a second, but come on. Okay.
You have a down button or something on it?
No. It's not the lamp, it's not the freeze. What is the freeze? Save and exit. No, I don't have a down button. I see what you mean now. Escape. I'm gonna escape. I escaped. Okay, good. So this equation works for any point. This one only for the slope and the y-intercept. Some students want to insist in determining the y-intercept first, something like this instead of this. Fine, you can determine this the y-intercept and then use that, but I recommend this. It's up to you. So y minus y1, obviously this is x1 and this is y1, x1, y1. So x1 will be -2, y1 will be 3, and the slope will be 2/3. Any questions so far? Is this okay, everyone? Yes? Okay, so we have to put everything together and determine the equation of the line. Okay, so this is y minus 3 equals 2/3 x plus 2. There is a minus in there in the formula, and x1 is a negative number. So that's why we have x plus 2. I have to distribute 2/3 and I have to add 3 to both sides. So I have 2/3 x plus 2/3 times 2/1. How much is that? 2/3, exactly, thank you. And plus 3. Thank you, Colby. Okay, now I hope we do not have any problems with adding fractions. So I have 4/3 plus 3/1. The least common denominator is 5.
Oh, wait, it's 3.
Okay, and so we multiply the top by 3, and 4 plus 9 is 13/3. Do you need me to refresh your memory on how I did that? Please say yes. Omar, so say it again.
Refresh on what?
On adding those fractions?
No, adding fractions, yeah, I'm good.
Okay, good. Yes, is this okay? Everyone? Okay, perfect. Now, the second part is asking us to do the exact same thing. So we're going to use the same equation. We're going to use the same point, but we have to find a different slope. This line still has slope m2, which is 2/3. But now, how do I find the slope of m1? I mean, the slope of line 1, which we denoted by m1. So if two lines are perpendicular, and a slope of one line is 2/3, what will be the slope of the other one? Say it again.
2.
But negative. The negative multiplicative inverse.
Okay.
So let's write this down. So for perpendicular lines, m1 times m2 equals -1. I know you remember it differently, but it's the same thing. You know it as m1 equals -1 over m2. If you cross multiply, you're going to get this. So instead of me telling you the negative multiplicative inverse of the first slope, I'll say the product is -1. So if this one is 2/3, the other one must be -3/2. But again, it's up to you. I don't want to change something that works. Okay? So if m1 is 2/3, m2 must be -3/2. So going back, we just have to put in y minus 3 equals -3/2 x plus 2. This time the slope is -3/2. Everything else is the same. The point is the same. So then -3/2 x. This time this is nice because I have -3. -3/2 times 2/1. Do I have to show that? At any point in time, I don't. But now I know how to correct it. At any point in time, I don't want you to think or not ask because I'm skipping steps. I don't want to skip steps unless everyone is following through. Is this clear? Is that okay? So -3/2 times 2/1, 2 will go away and I'll get -3. And then I have to bring the 3 to the other side. This one. This one goes to the other side. So then this is the equation of the line that is perpendicular to the given line and passes to the given point, -2, 3. Is this okay, everyone?
So far, so good.
So far, so good? I don't want to leave anyone behind. Is that okay? Yes? Brady, are you okay? Everyone okay? Paige? Okay, perfect. Moving on then. Now, this is extremely important type of problem, being able to read from a graph, especially because we are going to look at chapter 2, which is all about limits and looking at graphs and graphing and identifying limits, etc., etc. Okay. So the graphical function f is given below. Say the value of, let's choose. I didn't put anything. I just want you to pick a number. Which number will you pick? Let's say I would like to pick 10 in here. What will you say? The function is not defined at 10, so I can give you a number for 10. So, but then what could I ask you to put? Anywhere between -3 and, right. If I ask you for anything else outside of -3 to 3, you're gonna say sorry. Can't give you any number. Okay, so let's say which one?
2.
Okay. So we want to determine f of 2. We draw a vertical line, or at least we imagine that we draw a vertical line at x equals 2. We see it crosses the graph of the function at this point, and now I have to read the y value. I have to approximate it. I have no idea what it is. So the approximation will be whatever you give me, as long as it's close to 3, I'll accept it. What would you give me?
2.8.
Acceptable, right? Estimate the value of, I'm going to ask f of -3. What will you say? 2. And now for what values of x is f of x equals 2?
-3 and 1.
Excellent. In this particular question, we are really asked to draw a horizontal line and see where the horizontal line crosses the function. It crosses at -3, it crosses at 1. Excellent. Thank you, Lauren. Perfect. I want to add here, oh, they're already here. State of domain and range. Estimate the values of x such as f of x is 0. What does that mean, first of all? When I say find the solutions of the equation f of x equals 0. What am I asking you to determine? Yes, please.
When it crosses the x-axis.
Yes, the x-intercepts, the zeros, or where it crosses the x-axis. So this is extremely important. So this, where it crosses the x-axis, that's one answer. The other answer is x-intercepts. And the third answer is the zeros of f of x. All mean the same thing. Where it crosses the x-axis is one correct answer. X-intercepts is the second correct answer. And the third correct answer is, I'm looking for the zeros of f of x. They all mean the same thing. Perfect. So let's see, where does this function cross the x-axis? It crosses the x-axis here and here. So whatever you give me, I'll be happy.
Like -2.5.
Excellent.
0.3.
Say it again.
0.3.
Perfect. Good, moving on. Any questions? Oh, domain and range, sorry.
Domain is X and range is Y. Am I remembering that correctly?
Yes, domain is on the x-axis, the range is on the y-axis.
So
Yes, Hannah? Sorry.
I have the, that's it.
Okay,
It's bracket -3, comma 3, bracket.
perfect. Omari, you wanted to give me the range if you want?
bracket -2,
Yes,
bracket 3.
excellent. Do we all agree with that?
Yes.
Perfect. Okay, moving on, find the domain. Let's analyze this function a little bit. I see here a function composition. I see a ratio, and I see a square root. This is not a friendly function. Every time we start combining functions like that, it's not a very friendly situation. Obviously, I have to state a restriction for the ratio. Why? Why do I have to state a restriction for the ratio? What do we know? What can happen with in a ratio?
Denominator can't be 0.
The denominator cannot be 0. Excellent. So that's my first condition. Absolutely. The denominator cannot be 0. Good. Now let's analyze the square root. So what's the situation with the square root? Can anyone tell us anything about the square root?
X squared minus 4 cannot equal negative.
They can't be negative.
X squared minus 4 cannot be a negative number. Did you hear what we said? Okay, perfect. So it means that I have to write x squared minus 4 greater than or equal to 0. It happens that the square root is at the top, so it can be 0. But if the square root were in the denominator, I would have said just strictly greater than 0, not equal to 0. We agree? Perfect. Okay, so then I have to take this aside because it's going to take more space than what I have there. Okay, I'm on page 5. And yes, a long time ago, I had like probably 25 or 30 pages written, and at that time, I wasn't thinking properly, and I didn't number them, and I dropped them. So it took me about 10 minutes to put them back in order. Okay, so we are looking at x plus 5 not equal 0 and x squared minus 4 greater than or equal to 0. Okay, let's start with the second one because the first one is very clear. The first one is just x not equal -5, obviously. But what type of inequality is the second one? Okay, so let's say what other type of expression is this? How do we call it? It's a quadratic, right? Right? It's a quadratic expression. I agree. So then what type of inequality is this? What could it be? If the left-hand side is quadratic, what kind of inequality could this be?
Not that much.
Quadratic inequality. Absolutely.
It seemed too obvious, and I didn't want to say it.
Okay, so it is a quadratic inequality, obviously. Good. So now we have to think and know Do not tell me to move 4 to the other side and take the square root. That's not allowed. It's not legitimate. Don't even think about it. So how do we solve a quadratic inequality?
You gotta use that equation, right?
So if you want to set the equation instead of this, and you will find the solutions, right? And then what? You have something, yes? You're on the right track. However, this is not the method I would use. I'll show you something else. You use the method you like, though. After we find the solutions, what happens? What do we need to do?
Take the one that's greater than 0.
Yes, but we have to study the sign. Correct.
Yeah.
Correct. You're on the right track. Let me show you the method I prefer, but you don't have to adopt it if it's not clear to you. Okay? So first of all, when we solve a quadratic inequality, please remember we have to factor. And we just talked about this at the beginning of the class today. So I know that x squared minus 4 is the difference of squares. I know it factors. We wrote it on the form, right? X plus 2 times x minus 2 on our agreement valid for life, right? So what do we do next? I like to use a little table. You don't have to use this table if you don't like it. But I like to use the table and study the sign of each expression. But what I'm really interested in is in the sign of the product. X is the variable in the problem, and it can be anything between negative infinity and infinity. Now, at the top, I only need 2 numbers. Where this quantity is 0, that's one number, and where this quantity is 0, that's the second number, nothing else. So where's the first quantity 0? When x is? Awesome. So I make myself a note, so that's for -2, and for this one? Right. Why didn't I put it in just yet? Because I want to make sure I put them in ascending order. So -2 and 2, that's the correct sequence. Perfect. Now, x plus 2, under one or the other is 0. Under which one? Yeah, it's a silly question. X plus 2 is 0 under, good. Now I would like to identify what happens with the product, specifically at -2 and specifically at 2, before we proceed. When x is -2, the product will equal, excellent, of course, because one of the 2 factors is 0, of course. Excellent. What happens at 2? Yes, because the other factor happens to be 0. Excellent. So now, x plus 2 and x minus 2. What type of functions are these? X plus 2 and x minus 2. What type of functions are they? Let me list a few. Exponential, log.
Linear?
Thank you. I'll put her out of her misery. Linear, of course. Both are linear. Positive slope or negative slope?
Positive.
Does it look like this or like this? I know I always look silly when I do that, but I like to do it. This or this? This one. Which means, what is the sign of this?
Positive.
Negative.
0, and then? That's it.
Oh.
Negative before it's 0, positive after 0, negative before it's 0, positive after 0. Mandatory. Both are linear functions with a positive slope. They have to come from negative and go to positive. Now I want to, for each subinterval, how many subintervals do I see here? 1, 2,
3.
3 subintervals. On the first subinterval, I multiply 2 negatives. What is the answer? The sign of the answer only. Excellent. On the second subinterval, I multiply one factor that is positive and the other one that is negative. What is the sign? And finally, on the last, I multiply 2 positive numbers, no matter what they are. Positive. Only now, I look here, and I ask myself, what do I pick? Which sign do I pick? Which sign is greater than or equal to 0? And there is only one sign that is greater than or equal to 0. Positive. So does this product, is it ever positive? Yes. For which x values?
It's from negative infinity to negative 2 to infinity.
That's it. That's the answer. Just for one part of the problem. So the first one was not -5, and the second one is we don't really write in. It's this mathematical symbol, x in the interval, negative infinity to negative 2, union to infinity. Okay. Questions about the table? Hannah, did you want to say something? I thought you said something.
No.
Is this okay, everyone? Sarah, is this okay, everyone? Do we understand what happened here? Okay, so now I have to intersect these. There are two conditions. This one says everything between negative infinity, negative 2 union to infinity, but this one says make sure that -5 is not in the final answer. So then, what would be the domain? Finally, we are ready to write the domain of function f. If anyone would like to dictate the domain of function f.
Parenthesis negative infinity.
Awesome.
Negative 5, which is parenthesis union, negative 5.
Excellent.
Negative 2.
Great job.
Negative 2.
I want you right here in front of me. I want everyone. I'm just kidding. Of course. Is everyone okay with this answer? Do we understand why? Do we remember parentheses, brackets? Are we okay with this? Yes, Vicky?
Yes.
Yes. Everyone else? Alex, are you okay? Any questions, David? Okay. Moving on then. So that's the domain. Moving on. Find the domain of this function. What type of function is this? Log. What do we know about log? We know that it's the inverse of the exponential. We know that. Log function is the inverse of the exponential. So now let's go back to exponential. What do we know about exponential? Do we remember the graph of the exponential function? That is quadratic. That's for the quadratic function. So the exponential function looks like this, or looks like this. So let's graph those, because I need them for later. Just a quick graph. This is an exponential function with a base greater than 1. Some of my students in the middle of the semester, they say, let me show you the other shape first. So here's the other shape. So one more time here, because it's maybe not clear over there. So the first one is increasing on all its domain. The second one is decreasing on all its domain. The first one has a base greater than 1. The second one has a tiny base, positive between 0 and 1, not 0, not 1, of course. Tiny, 1/2, 1/3, 1/5, 1/16, 2/3, anything between 0 and 1. So sometimes my students ask me, some of my students ask me in the middle of the semester, hey, Rosa, can I still get a passing grade or good grade or something like that? So I say yes. If moving forward, your grade from now on follows an exponential function with a grade base greater than 1, the answer is yes. That's the fastest growth. Okay. Mental note, don't present this joke ever again, nobody. Good, okay. Moving on. So what is the problem here? Exponential functions are friendly. As you see, no restrictions, this is what I like. But their range, please remember, the range is 0 to infinity. The range is 0 to infinity. And that would be the domain of the inverse function. So the inverse function is this, or the inverse function is this. So moving forward, please remember, the log function is the inverse of the exponential. That's why it's defined on 0 to infinity. So the inverse function, which is log, is defined on 0 to infinity, which is the range of the exponential. So I like to present these functions together. So the exponential function is defined on all real numbers, taking range or taking values on 0 to infinity. But the log function as being the inverse function, these are reversed. So 0 to infinity, negative infinity to infinity. So exponential function friendly, I don't have to worry about it. I don't have to worry about the domain. But a log, I do have to worry about. Why? Defined on 0 to infinity. So please remember these together. And I forgot to say, I want to say it, but I forgot today. What I recommend is create a tiny logbook. May I? Yeah. So something like this, in which you write, today I refresh my memory on the exponential log, and here are the graphs, and here are the domain and range, and this is how I determine the domain of a function that has a radical at the top and the polynomial denominator. This is how I solve a quadratic inequality. I cannot take the square root from both sides. I have to factor and study the sign. And this will always serve you well, because you're not gonna, by the middle of the semester, you're gonna have a notebook like this, and it's not easy to go through everything. But if you condense everything that you refresh your memory on, you forgot, or something new that we do every day, this is always helpful. Okay, so please do that. Unless, again, you have a different game plan and it works for you, and I'm fine. Okay, coming back here then. I see log is applied to x plus 4. Whatever log is applied to, whatever it is, it must be what type of number? So then I have to write that x plus 4 has to be positive. And that's an easy story, so I have negative 4 to infinity. Notice that you cannot include 0. This is what it's called what? For this function. Very good. The vertical asymptote is x equals 0. So this function has a vertical asymptote x equals 0. This function has what type of asymptote? Yes, y equals 0 horizontal asymptote. And of course, the graphs will always be symmetric with respect to this line. Always. The graphs of two symmetric functions will always be, of two inverse functions will always be symmetric with respect to y equals x. Okay, find the domain of the function tangent x plus pi over 6. Any questions on the previous one? Okay. What type of function is this? Yes, it is a trigonometric function. Is there a potential problem with tangent?
Yes.
Yes. So we have the 6 trig functions. Only 2 of those are defined everywhere. Which 2 of those are defined everywhere? Yes. Yes. These are the friendly ones. These are not. Because they're all ratios. Tangent is sine over cosine. When cosine is 0, then tangent is in trouble. Cotangent is cosine over sine. Whenever sine is 0, cotangent is in trouble, meaning a vertical asymptote, right? Same thing here, secant is 1 over cosine. So every time cosine is 0, secant doesn't exist. And here this is 1 over sine. So if it's c, it's the denominator is with s. If it's s in front, the denominator is with c. So secant is 1 over cosine. Cosecant is 1 over sine. So this is in trouble when sine is 0. So tangent has a difficulty. The difficulty is if cosine of x plus pi over 6 is 0, then tangent does not exist. So for tangent x plus pi over 6 to exist, cosine cannot be 0. Okay, so now let's look at the unit circle. What type of equation is this? I'm trying to solve this. What type of equation is it? Okay, I'm going to give it a few names and you say stop. I'm looking at Kobe, he's going to jump on it immediately. Square root, rational, log, radical, exponential, quadratic, maybe I said that already, polynomial, quadratic in form, linear. Is it a radical?
Rational.
Is there ratio?
Radical.
Is there radical?
Median.
Thank you. You did say that? My apologies.
No, I said on the one before, on the tangent.
Oh, okay, my apologies. I'm sorry. I didn't say.
No.
Okay. Hannah said that, but I didn't hear. I'm sorry. Not intentional. It is a trig equation. Perfect. Okay. So then we have to go back to the unit circle. Here's the unit circle. And can anyone remind me where is cosine 0? Okay, let's think. Where do we measure cosine? So we have the x-axis and we have the y-axis. Where do we measure cosine? Do we measure it on the y-axis or we measure it on the x-axis?
I think it's on the x-axis.
Excellent. We do measure it on the x-axis. So where on the x-axis will, for which angle will then cosine be 0? Excellent. And? Excellent. Thank you, Hannah. Yes, indeed. At pi over 2, cosine will be 0, and at 3 pi over 2, cosine will be 0. So, although the equation does not ask us to solve, or the function doesn't say whether we are only looking at one complete circle, so they want us to determine the domain in general. So we're going to have to take that into account. And no, I have 5 minutes left. Don't ever let me go over, okay, please. I normally don't, but sometimes I get carried away, so it's not disrespectful if you just tell me, hey. Okay, so then we have x plus pi over 6 could be pi over 2 plus 2 pi k. I'll explain. Or x plus pi over 6 could be 3 pi over 2 plus 2 pi k. K is an integer. It could be 0, it could be plus or minus 1, it could be plus or minus 2, etc. And we have to specify that when we solve a trig equation. And if we need to solve it in general, not on a specific territory, then we have to write that k equals 0, plus or minus 1, plus or minus 2, comma, and 3 dots. So now we have to solve both equations for x, moving pi over 6 to the other side, and that's the final answer. So x equals pi over 2 minus pi over 6, 90 degrees minus 30 degrees, in other words, pi over 3, plus 2 pi k, and x equals 3 pi over 2 minus pi over 6. The least common denominator is 6, and this one needs a 3. So 9 minus 1. So I got 4 pi over 3. So this is what x cannot be. So we did not write the domain yet. So I will say domain of this function f. Maybe we want to present it as a set builder notation. I would write pi over 3, comma 4 pi over 3, both of them plus 2 pi k. I don't know how else, anything, sorry. I meant to write anything but. So it's, yes, it is, yes, x minus. Let me write it again. Do not write that, sorry. So we write x such that x is not pi over 3 plus 2 pi k, or we can write x not equal pi over 3 plus 2 pi k, comma, x not equal 4 pi over 3 plus 2 pi k. And it's up to you how you want to write it. I accept it in both ways. Where k I have to write is 0 plus or minus 1 plus or minus 2, such and such. So it can be anything but. We have 1 minute left, and let's see, at least let's just discuss number 6. Let's start by 1 minute discussing 6, and we'll continue. So it says, graph the function y equals e to x plus 2 minus 3. Can anyone just list the base function and the transformations on this, in case you remember those? Yes, Hannah?
The base function is e raised to x.
Right, which is this, and then what transformation will I have to apply?
You move it to the left 2 times
Very
and then
good.
down 3 times.
Exactly, that's it. Perfect. So this is e to the x. It is shifted to the left 2 units and shifted down 3. So this I would like to continue next time and finish it up